Just to give you a very quick intro, so you already heard a little bit about the company, but I'll just give you a very quick overview from when we began to where we are now. So we're based in, so as I said, I'll just give you a brief intro to the company. So the original company was formed in 2002 in Austria, and we were actually forensic accountants at that point. Then obviously with the growth in digital forensics and the need for this in basically every investigation now, we then established T3K Forensics as you know it now in 2007, and then started to do digital forensic services into 2011. So further forward, we have a small office in Germany, and as I mentioned before, we've been around since 2002, and as already has been said, we do several things. So we develop software, specifically some mobile forensic software called Leap, which is what I will focus on today, and I will talk a bit more about that soon. We also offer mobile forensic training courses. So we run these for law enforcement only, and we have various levels of training courses from beginner to advanced. And we've trained in excess of 200 law enforcement officers in the last 5 years in these. So, and then additionally, which is also part of what I do, we do actual digital forensic cases for Austrian police. So we get on a weekly basis cases that the police need help with or don't have resources to do, and then we do those. So we're actively involved in digital forensics, and obviously we're up to date with all of the latest technologies and practices that involves. So okay, so let's just talk a little bit about challenges in mobile forensics, certainly from what we see and from what I've seen from my experience working in the UK and also now working in Austria. The first kind of obvious thing really is probably problems with the enormous data volume. So I think everybody knows that every smartphone, for example, now can hold a huge amount of data. So a modern smartphone, minimum 64 gigabytes, 128 gigabytes, some of them even up to a terabyte of data now. Obviously, dealing with this volume of data in criminal investigations is becoming more and more problematic. It leads to growing backlogs. So you have so much data and so much information to try and search through that it takes a very long time, which means obviously other cases get delayed and you end up with huge backlogs basically. Coupled with limited resources, this then starts to become a real problem, and delays start to happen, which things like state's attorneys and the courts and the people involved won't be very happy with. So all of these things, they've been a problem now in digital forensics for a while, but it's only getting worse. This is why we decided to produce this product called Leap, which tries to address and help with some of these pain points basically. So let's just go on to the next slide. So yeah, as I mentioned, with the data overload problem, I mean, as you can see, and as you probably already know, your average device or smartphone now will contain at least the things that we've got listed here. So thousands, tens of thousands of videos and photographs, tens of thousands of emails, communication data like WhatsApp, Signal, Telegram, etc. Obviously, quite often there'll be multiple languages and dialects involved, huge amounts of browser history, location data, and so on. So you can see that there's, for a person to basically, try and sift through this information manually is really difficult, takes a very long time, and it's very hard to establish interesting information from such a large volume of data. So we essentially wanted to try and help with that. And that's where Leap comes in. In terms of the process at the moment, I'm not sure how exactly it works in India, but I imagine you follow similar processes to other parts of the world in terms of the kind of workflow when it happens with digital forensics. So obviously there's a point where you have the actual seizing of the devices. So you're taking smartphones, tablets, PCs, things like that away from people to be analyzed. Then there's the time that required to do an actual data extraction. And then after you've done that, this is the point where delays can happen normally, because this is where the analysis portion needs to take place, often with some kind of manual inspection. And obviously, at that point, manually inspecting terabytes of data takes a long time. Even with standard forensic tools, you still have to essentially be a person sat there actually looking through the data. Even if you use keyword searches and things like that, it still takes a long time. So what we really wanted to try and do was to automate and speed up this analysis part. At the moment, more specifically for mobile devices, that's what we designed the tool to do. And I'll show you that later, but we also do deal with media sources as well. So there's a couple of case studies that you can see on the screen at the moment, which we just picked out. So, you know, for example, authorities having to deal with 14 terabytes of material, which contain more than 3 million photos. You can imagine the amount of time and resources that it takes to be able to do something like that. It's just, you know, it's becoming not realistic to look through this amount of data in the traditional approach. There has to be a better way to do this. There has to be a more automated, intelligent way. So that's where we are trying to come into the workflow with like that. So in terms of what Leap actually is, so Leap is an analytical platform. So it isn't a data extraction tool. It does not extract data from a device. You still need, for example, with mobile devices, you would still need Celebrite, UFED device, XRY, Hancom, Oxygen. So these kind of tools, these are the kind of big tools in the market at the moment, and they specialize in, you connect the mobile device to that and it extracts the data for you. And then once you have the data, typically they provide some kind of viewing tool where you can just look at all of that data and try and pick out interesting things to make a report. So we're not an extraction tool. We work on the data after the extraction has taken place. What we are trying to do is be another part of the analysis, basically. So instead of having this manual viewing platform that they provide, which means, you know, a person has to sit there, wait for the data to be loaded into it, then scroll through all of the text messages, run some keywords, look at all of the photographs, look at all of the videos. All of this is taking days. You know, maybe actually the officer or the people in charge of the investigation need to know some information quickly about this device, and it's just not possible to give them that using a traditional method. So what we're looking to do is give you this automated reporting workflow, which should hopefully accelerate the investigation at the start and give you access to a really nice overview of what's on the device, whether or not it's relevant, and also be able to give you an automated report which you can use instantly for intelligence or for an interview and things like that. So in terms of why Leap is special and different, we basically developed some leading class AI, which we've embedded inside the system. So we use this AI essentially to do several things within the system, and primarily we do object recognition, where we can detect automatically different objects inside images and videos, and I'll show you actually what that looks like later and go on to that a little bit more. And then, as I said, the sort of key part is this automatically generated report in a very fast way, so that you can get access to useful information from a huge amount of data very quickly. That's the big advantage. So, as I described, the previous workflow, it works okay. However, at the moment now, with increased data volumes and the increased number of devices, it's just not really practical to keep doing it that way. So what we believe, you know, people need now will be something that's automated, obviously simple to use, so there's not a huge amount of training requirement up front, and then obviously speed. There's certain situations where people use our software where speed is absolutely key. So it could be at a border point, it could be in an investigation where, you know, you have basically a victim that's missing, or you have a suspect who's you know, on the run or something. You need some information quickly from these devices so that you can maybe get some actionable intel and actually, you know, progress the investigation in real time. It's not really practical always to have somebody sit there and look at the data for 2 days before they can establish, which part of it is useful. So this is what we're trying to really sort of help with. In terms of where LEAP positions itself, as I mentioned, really, so you can do forensic triage. So this might be that you have 20 mobile devices or media sources, and you need to know which of those 20 are actually relevant to your investigation, that actually contain something useful. Because at the moment you could spend several weeks looking at all 20, and in the end maybe only 5 of them are actually got relevant information, but it's taken all of that time to establish that. So using a tool like LEAP, you should be able to quickly pinpoint different media sources, different mobile extraction data that's actually relevant. As I already mentioned, fast operational feedback. So with this automated report and this overview of what's on the device, you get instant feedback as to whether or not the device is relevant, but also maybe some operational information that you can use instantly, the officer can use to then progress the investigation a lot quicker. And then the final part is this link integration. So within LEAP, we have some link analysis capability where we can compare different mobile devices with each other at the same time. So you can compare things like communications on the device, address book, internet history, and you can also run like a keyword list across multiple devices simultaneously, and then see, if you've got some keyword hits in which one, then again shows you which one might be relevant. For example, we have customers using this system in things like child abuse investigations or terrorism investigations, where the presence of certain keywords and certain names and things like that is immediately relevant. So it means that when you've got this hit on the device, that it's immediately something interesting on there just by having this keyword list. So in terms of the workflow, so as I mentioned, we're not a data extraction tool. We don't do that. We're complementary to the existing extraction tools. So what we will do is ingest the data from these common platforms, do some automated analysis, and then give you this automated report. And the whole point of the system is it's very quick. Typically, you can get once the extraction is finished and you have the data, once you put that through LEAP, you can typically get an automated report in minutes. So it could be 5-10 minutes. Basically, you'll get some results already to start looking through and start using that for to progress the investigation. So in terms of different things that we support, so I already mentioned mobile device extraction, so things like Celebrite, MSAB, XRY. And we also support media data. So by that, what I mean is basically images and video files. So you could put thousands of images and video files into a folder, basically, or into a zip file, and put that into LEAP, and it will automatically run our object recognition across it and find interesting things in there, and then give you the automated report. A couple of use cases that we've got. So I talked about the forensic triage. So in this example, you've got the case officer or the forensic analyst, depending on how the workflow works in your organization. They essentially do the acquisition of the device, so they use a kiosk or similar to get the data from the device, and then that data is automatically pushed to the LEAP server, and then you automatically get a report back. At the same time, that raw data is uploaded to storage so that you can still use that for further deeper analysis if required. So when you've got the automated report, it might be that actually, that you can see from this report, there's some very interesting either images, videos, key terms, people's names, things like that on this device. That means that not only do you now have a nice overview, but you now need also a further deeper forensic analysis, so you can still do that. So this is a very nice automated workflow and allows you to triage devices very quickly and establish which ones are actually relevant to the investigation. Another potential workflow we could have, so this might be in a digital forensics lab, for example. So you have the officer who submits a case to the lab. The forensic technician or examiner in the lab, again, performs the extraction using the standard forensic tools. At this point, you would then put this extraction through LEAP to generate the automated report. You could also put this extraction into the viewing tool provided by the extraction tool in the usual workflow. So both things can be done in parallel. The advantage of this is the LEAP report will be much faster. So this can instantly go to the officer and also to another forensic examiner. They can look at this LEAP report, decide whether or not this is relevant, and also this can also focus the more deeper examination that you've got here, the expert examination, quickly, so that they can delve deeper into certain areas that have been highlighted using the LEAP report. So again, it just speeds up even the standard forensic workflow where you have to have a more in-depth analysis. It still speeds up that process to quickly highlight areas where that analysis can focus on. And then obviously at the end, if required, you still have your expert report. So you still have the forensic examination process in there. It's just that LEAP is an additional component which helps to speed things up and also helps to get information to this officer a lot faster, because the time taken to go through this route here will typically be several days, just because obviously to do an expert examination, you need to be thorough, and the expert report is much more in-depth. Whereas this part here is automated, and a LEAP report can be given straight away to give a very nice overview and indication of already what's on that device within minutes of the extraction happening. So I mentioned a couple of potential use cases there. In terms of kind of general use cases where, you know, the system could be used in, there's obviously quite a lot. I mean, this is just a few that we've picked out. It could be that, you know, the organizations that you work in have something more specific, and in which case, you know, we can customize the system to fit other use cases as well. But typically things that we have LEAP running with at the moment, certainly identity verification and human trafficking. So for example, because of the speed and the automated report component, you can use LEAP at border points and in human trafficking investigations where, you know, you need to get real-time information quickly. It's not practical to just get all of this data and then load it into some kind of manual review platform and then wait days while this happens. Typically also those platforms require a lot of training, whereas with LEAP it's very straightforward, and I'll show you that later, and the report is automated and simple to understand. So any kind of use case that requires speed, this is where LEAP has a huge advantage at the moment. Obviously things like terror screening, organized crime and child sexual abuse, because we can automatically detect different types of images within the data, within the media data on the device, we can quickly focus on things like weapons, car license plates, child abuse images, etc. Things like documents, ID cards, anything like that really. So, you know, we can really quickly focus the analysis, you know, to actually fit some of these use cases and get you information much quicker. We also, as I just mentioned quickly, customize classes. So even though out of the box the system supports around 15 different classes, we can obviously train the system and customize it so that, you know, if for example a particular customer needs us to find I don't know, maybe it's like a gang tattoo or something like that, some kind of image like that, then we can train the system to automatically detect and put that into a report as well for you. So it's very flexible and very customizable. So I've talked quite a bit now, and I think, yeah, soon we'll get on to the point where I'll actually show you the system. It'll be a bit more interesting to see a walkthrough, but we'll just reiterate again the advantages of LEAP. So it gets you this fast, actionable intelligence straight away. Potentially reduces number of devices that require a full examination. So this is the triage use case. Informs examiners prior to a full analysis. So again, this is where, you know, it's not meant to replace the forensic expert or anything like that, because that's obviously, you know, that's not possible. There's always a place for an in-depth forensic analysis for an expert to look through specific parts of the data and produce a report. But using something like LEAP can speed up the process of finding this relevant data and then be able to do this in-depth analysis on specific areas a bit more quickly. And then obviously, yeah, the actual analysis that you get from LEAP is standardized every time because it's an automated process. The report that you get produced is the same every time in terms of its structure. Obviously, the content depends on the data that you're analyzing, but the structure is always the same. So it's very, very nice to have a standardized approach that way. In terms of how Leap is actually configured and set up, there's a couple of different options. So you can have a workstation or a laptop, for example, running Leap, and then essentially you would transfer the data to that, and then you could analyze it on the device itself. This obviously could be useful either if it's in the field or in some kind of triage situation. The other option would be enterprise setup. So like Leap has been designed ideally to be run as a hosted system. So you would have it installed on a central server, and then you can access the Leap front-end GUI via web browser from any device, and then you can run analysis and look at reports from a web browser. So there's a couple of different options, and obviously it depends on the use case, or it depends on the organization as to which one is most appropriate for them. Right, so before we come back onto this, I will give you a live run through. Just give me 1 second. So,
Gareed, actually, you have some questions in the chat box. You can just answer that one, if possible.
Oh, sure. 1 second. Let me see. Okay, so there's also a question about whether or not this involves SaaS. It does not, no, but it can be deployed in the cloud if necessary. And there's also a question, yeah, no problem. And there's also a question about current and future challenges in smartphone forensics. So that's slightly out of the scope, but I can give you a small flavor of things that are an issue at the moment. So I think the big one probably, obviously we talked about data volume, but the other one is probably the biggest issue is encryption, and also the proliferation in the number of different apps that you can get now. So even the best forensic tool on the market, let's use an example like Cellebrite, which is probably the market leader. They still have issues, obviously, circumventing encryption, but the other biggest issue is they cannot keep up with supporting the number of different apps that are available on a device. So even though they have, a huge team of experts, there's millions of apps available on the app stores now, so it's not possible, to support all of those out of the box. So you still have to have some knowledge and do some like SQLite examinations and things like that. So I would say at the moment, biggest challenge is data volume, accessing the data, so encryption, and also then decoding the data from different apps. That's a good question from Maya there. So I'll answer a few of these, and then we can come back at the end, and also have a question and answer section. So I'll just answer a couple more. So there's a question about more chances to hack Android. It really depends. You've probably all heard about Checkmate, which is essentially a security flaw in iOS. So you could argue at the moment, actually, iOS is less secure in some ways than Android is, just because the Checkmate exploit is hardware based, so they can't patch it. So at the moment, a lot of the new forensic tools are using that, and that allows you to get a full download of the content of an iPhone, which was not always possible before. So I would say, to answer that question, it depends on the device, but in general, at the moment, some of the older iOS devices are now easier to actually access and get data from. So I'll just, like I said, give you a live demo and show you what Leap actually looks like. So as I mentioned, the front end of it is web-based, so you can access it through any web browser. Typically, we recommend things like Chrome and Firefox, but it will work on any browser. So if we just log in. Okay, so in terms of the overview, so there's several different sections that you can see here. Device analysis is where you would run your mobile device extraction analysis. So this section is specific to looking at mobile data, and I'll show you what this looks like in a minute, and I'll show you what a report looks like as well. We also have here the media analysis section. So this is where you would put your raw media data in there to run the object recognition. So again, looking for objects that we automatically find, like weapons, ID cards, passports, cars, CSA material, terrorism material, things like that. So again, this deals with both images and videos, and it could be extracted from any source. You just need to obviously extract the data first and then put that into Leap. The Interlink is when I talked about this correlation analysis, where we can compare multiple extractions together. You can run keyword lists across multiple extractions. and it gets you some nice correlation information very quickly, and you can see, you know, which devices are kind of related to each other and things like that. And then screening, this is where you can apply various filters. Watch lists are the keyword lists that I mentioned, so you can create this watch list of interesting keywords relevant to your investigation, and then quickly run that across mobile extraction data, and then, you know, obviously get this hits in the report very quickly to give you a very quick overview of what's on there. And then pictures, this is where we can basically, so I was just saying about the pictures, this is where you can upload essentially pictures of people that you want to find via facial detection in the system. So you can upload a picture of a suspect or a victim, and then you can run this across the extractions, and we will do face recognition to find those images. And I'll show you what that looks like in a report in a minute. So yeah, various different sections. Like I said, the key things are, you know, device analysis for mobile devices, media analysis for media data, and Interlink for doing comparisons between mobile devices. If I just go in here to show you what it looks like, so we've just got a few examples in here, and I'll click on this one. So you can see we also present you information from the extraction, so things like that are useful quickly, things like telephone number, the IMEI number, the IMSI number from the SIM card, and things like that. So, and also, yeah, the ICC ID. And then down here, this is where you would essentially choose which profiles to use and choose which types of analysis to run. I'll go through this in a minute in a report, but you can see there's various different options of things that you can choose to do. And also, you can choose watch lists here, and then you can choose which faces that you want to run the facial detection across. So all of this, very straightforward, can be done manually like you see now by a user, or you can actually create an automatic profile which contains different options of your choosing and also different report languages, and you can have that as an auto run profile so that you don't have to have a user necessarily choosing all of this every time. You can create a default profile, and then every time a new extraction or new media data arrives in the location that's being watched by the system, it will just run this analysis automatically, and then a report comes out at the other end. So, you know, you can basically automate this workflow very, very easily. So in terms of what a report looks like, I'll give you an example of what we've got here. A couple of these are based around like a terrorism type scenario. So I'll just give you an example of one here. In terms of reports, we have PDF versions and also HTML. The HTML you can actually review inside the browser, which also gives you some options to interact with the tables, whether maybe you want to hide different sections because they're not relevant, things like that. So, so what the report actually looks like, the first thing you would get, so if you've used a keyword list or what we call a watch list, the first thing in the report is any hits based on the key terms that you've put in there. So in this example, we've just got some terrorism type keywords where you can see the keyword that we're looking for, and then this is showing you here the messages and the actual location of the hit inside the message. Obviously, you also get things like the information about the message, like the name, number, and when the message was sent or received. So we're giving you, again, the whole point of this is to give you this information very quickly and easily in a report without having to actually, you know, use another type of tool where you could run a keyword list, but it would still have to then look at all the hits. You'd have to then bookmark the hits maybe, and then actually manually create a report and then, you know, give that to somebody. So it just takes a lot longer, whereas we're trying to automate and speed up that process. Also here, you could, it's not limited to just looking for words. You can look for things like location coordinates or maybe MD5 or photo DNA hashes. For those people who are not sure what that is, basically a hash is essentially a mathematical, it's basically generated by a mathematical algorithm, and it's effectively a unique fingerprint of that particular file. So typically, you can use this to quickly identify, you know, the same files on different devices. So in this example, you could have a hash watch list of known files or interesting images or videos that you know that will be relevant to your investigation. You could use that with the hashes to quickly locate those on the device. So we also have an OCR engine, so we can find text inside pictures. particularly useful if somebody is obviously, scanning things or taking a photograph of something that contains text. You can try and find that text using keyword and watch lists. The text has to be clear. It can't be, very poor handwriting or very blurry images, will be difficult to detect. So it has to be clear text, but still gives you a big advantage of being able to find text in pictures, which otherwise might not be possible. So again, we'll just screen through this. So you can see it's split up into different sections. So we've got some hits in the URLs, we had some hits in images there, and we had some hits in messages. So let's go down a bit more. Okay, so then the first kind of main part of the report is an overview of the device and also information that the user would have put into the system. So you can see here we've got things like the device type, again, the phone number, the IMEI, ICCID, all this information, very, very useful, because it could be, the officer can use some of this information to quickly go to the network provider, either get a billing list or get some kind of subscriber information. So it's just a really nice quick overview that they can then use to further their inquiries by doing their normal investigative work, where they would contact the network provider and ask for this information. So it just gives them that in a nice table here. In terms of the automated analysis, so we've got things like we look for different countries that we can detect on the device, and we show you that in terms of the call history and also the messages. So again, it depends on the investigation. It might not be relevant to every organization, but certainly when we have use cases to do with trafficking and basically border control and things like that, and also terrorism, it's very, very relevant sometimes to know if a person, or this device at least, has been, or communicated with certain countries. That can be particularly useful to know that. To establish this manually, just looking through the data would take a long time, so we can do this instantly for you. We do the same thing in terms of the contacts in the browser, again, looking for different countries within those. And obviously, when it comes to locations, we detect locations, all locations on the device, and we also look for what we call generated locations. So there's typically less of these on devices that you will find, but when I say generated locations, what I mean is looking at things like EXIF data from images, where you've got times and dates, and you've also got geolocation coordinates embedded inside those images. Then we'll look for that and basically plot those onto a map, and try and give you also an idea of movement if we can do that based on dates and times from within that metadata. Also, the same technique is used to generate this chronicle, where you've got an activity over a period of time. In this example, we can see here somebody moving through 3 different countries, so Greece, Italy, and Austria, over the space of 18 months or so. Again, depending on the investigation, just knowing that this is happening could be instantly useful, and would otherwise take a lot longer to establish that. And also, you can see terms of activity when things like basically activity when the device is being used heavily, again, could be very relevant. So we also look for languages. We support a huge range of languages, over 270 different languages, and we also support some dialects. At the moment, the dialect analysis is specific to Arabic dialects. That again was based on feedback we had from customers that needed to focus on that specifically. But obviously, going forwards, this is can be customizable. We can add further languages, further dialects that can be detected this way. But you get an idea of how this is happening. Again, the fact that certain languages are used on the device, and to get that information quickly could be really relevant to an investigation. We also aggregate the first calls and the people that have been called or spoken to the most. We do the same with the SMS. And same with chat messages. So by chat messages, what I mean is things coming from things like WhatsApp, Viber, Telegram. Essentially, anything that the forensic toolkit used to do the extraction is decoded. As long as that has decoded the data, then we can access the data and then display it in this report. So also, not in the new version of this software, you'll also get an aggregated display of the last messages, the last calls and things like that on the device. So you'll get not only the first ones, but also the last ones, which gives you a better, broader overview of what's on there. Again, top contacted persons from chats and from SMS. We also show you the top 10 visited websites based on number of visits. Again, top 10 by default, could be customized if necessary, but yeah, depending on the type of investigation, you know, something like this in a terrorism investigation, or it could be in a child abuse investigation, there's certain websites or searches that have been carried out, let's say, that again are instantly relevant because you know that, you know, those sites contain that kind of information. We also aggregate all the user account information that we can find on the device into a table that you can see here. So, you know, typically we get a lot of different user accounts. For example, things like Gmail, Facebook Messenger, you'll see Skype down here, WhatsApp. So all these things, just to get this information quickly for the investigator especially, can be really, really useful. You know, they can maybe do some open source research straight away from the fact that they now know the Facebook Messenger username, the Skype name, and things like that. So it just empowers the investigation with information that otherwise would take longer to get. That's the bottom line. So we'll just come on to the media. So the first part here is where we've essentially done the OCR that I mentioned. So the keyword was HAL. And you can see that we're basically in this screenshot here, the keyword is there. So we've just shown you which picture actually contained the keyword hit. And then we also give you information about that image. For example, the file path of where it's located, MD5 hash, timestamps, and etc. So if this image is relevant, you know, maybe this keyword is particularly relevant to the investigation, you now know exactly where it is without having to have, you know, scrolled through all the other images or try and do this manually. You know exactly that you can go to this location, and maybe actually in this location there's another 50 images that are relevant to the investigation, and you've already found them really quickly because you know where they are. And the same with the hash. You could quickly do a hash search in another tool, for example, to find that. So yeah, this is more examples of things like, you know, keyword bomb, and you can see that bomb is in the screenshot there. So in terms of, this is just an example of what the ID card identification looks like. So we're automatically finding these images of things like this ID card, passports. So typically a user could scroll through 50,000 images. It might take a week, and yes, you will find these things, but we can do this in minutes and just focus the investigation on things that are actually relevant and not have to then search through all of the media data just to look for these things. So you can see how this is working. Important to mention, as you can see here, you know, you can see this is not like a faked report or something. This is from a real extraction with real random data in the extraction, and because of that, you will get some false positives. So the way that the object recognition functions, you will always get some false positives. What we try and do, we've optimized our system to basically create a balance, obviously, and reduce the number of false positives while still giving you a high percentage of true positives, which is obviously very important to make sure that something key is not missed during the analysis. It is possible, you can see these percentages here. This is essentially, you know, the threshold setting. So we're giving you, this is 47% likely to be a passport, which obviously we can see that it's not. It is possible to change the thresholds in the system, which would then reduce the number of false positives. But obviously, you know, we would do this in conjunction with the customer to make sure we get the right balance, essentially. This is what the license plate detection is, how it looks like. So you can see when we're not just looking for cars, we're actually looking, you know, we'll look, the object recognition algorithms will detect this as a car, but then also then the object that it's actually looking for is the license plate. So it focuses on that. Just give you some, yeah, you can see how that's working. Again, you can see a few false positives there. Face detection. So what we have here, Prince Harry, we have a different, so there's pictures of Prince Harry in the extraction, and we have a different image that we've used as a sample, and the system has then scanned this media and located something that it believes to be the face of Prince Harry, which you can see is correct in this case. if we go in here, the picture that we've uploaded is a different picture. So we're not looking, just for the same picture. That wouldn't be useful. It's a completely different picture. So it still locates that data using a different picture. So I'll just go back to this. Let's find Prince again. In the same way, you can see, so this is actually the CEO of T3K Forensics. And again, so we've uploaded a random picture of him into the system, and then it goes through the media and locates other pictures that it believes to be him. It's even picked his face out on this travel card that you see here. So, and again, yeah, and on the driving license. It's also not just limited to single headshots. If it's a group of people, we can still pick out particular faces. So again, you can see our CEO here with 2 other people, and then we've got the rapper here, which I again put a different picture completely in there, but it's still located his face, even though there's other things happening in the image. So we believe things like facial recognition again could be very, very useful to do this very quickly, because maybe just even having a picture of a suspect or a victim on that device is absolutely key to the investigation. Immediately then you could, use that in an interview instantly, and, the person has to explain why that's there. It might previously take days to find that one image that's actually relevant, and empower the investigation in that way. So in terms of weapons, you can see how that's working. Also facial masks. Again, we've got false positive there. Because this is based around terrorism, we've just highlighted things like the IS flag as an example, but we can also train the system to look for other different symbols as well. As you can see there, things like far right extremism and documents. So we can look at automatically pick out documents from the device, and again, maps and screenshots. So all of this, the whole point of this is all obviously in the extraction. It can all be found by a person manually. It's all in there. It's all mixed in with lots of other random pointless things like icons and web cache and things like that, which, as a human, you'd have to look through all of that first before you could actually locate useful things. And then you have to produce a report. So we're doing this part of it automatically for you and putting it in a report at the end. In terms of how we, this is an example of screenshots. So it could be, it's quite common that people take screenshots of messages. So I mean, that is effectively a picture at that point. But using either a watch list or using our screenshot detection, you could still find messages that maybe are not even in the normal forensic toolkit, because it hasn't been able to decode that. So again, you can quickly highlight useful information if somebody's taken a screenshot of a message, for example, or financial transaction like this, for example, flight booking. We'll just go on to the video analysis. We also do. We do this in a quite a unique way. So typically for a person to, examine videos manually, it takes a very long time, because you have to watch a video, or even, skipping through different scenes, in order to not to miss something in a scene. It just takes a long time for a person to do that, or is also open to some potential error, really. So what we do is every time a scene changes, we will take what we call a keyframe, so like a snapshot of that scene, and then we run that through our object recognition engine. And that then picks out, again, different classes based on obviously the percentage likelihood of whether it is that class or not. Again, this is to do with threshold settings that we can tweak, but by default we want to obviously minimize false positives and only give you things that are relevant. So in this, for example, you can see multiple objects in here. So we've got a gun and the person that's got a mask on. And in this example here, again, so this is from Stargate video, which is around 45 minutes. Again, you can see it picking out weapons and things like that. So just gives you an idea of, scanning a lot of video data. We can do that very, very quickly. So with the right hardware and the right optimizations, we can scan hours of video in minutes, basically. We can also, up to 200 frames per second, and we can also look through approximately 4,000 images per minute. Again, based on the fact that you need the right hardware to do that. By that I mean a strong GPU, and a strong CPU and RAM. So nothing too out of the ordinary, but we can certainly, you know, scan a huge amount of data very quickly and get you this automated report. So I'll just quickly show you an example of a media report. So let's have a look at maybe the license plates. Oh, hang on. Yeah. So it's the PDF version. Just another example of license plates, you know, so you can see there's lots of other stuff happening in the background of these images. We're not just, you know, taking a picture of a license plate on a table. You know, there's actually a lot of other things that the AI has to try and distinguish. So that's the difference really, is that, you know, the object detection is much better than just simple image detection, because it's actually focusing on specific objects within the image. Just to give you an example, yeah, you can see that. So yeah, you can see the different kind of scenario, different types of vehicles. You know, it doesn't really matter. It's just looking for the actual license plate. And the same if we go down, you'll see the same with videos. So again, license plates from videos. So yeah, and give you another example, general video analysis again. So as you can see, we've got some wild animal detection happening there. But this just gives you a really nice overview of, you know, you can imagine, even in this example, there's only 14 videos, but actually some of the videos, like one of them's like an hour long, for example, you know, for a person to look through even 14 videos, you know, around 3 hours of runtime would take, you know, at least, you know, maybe an hour, maybe more. And we can actually run this much quicker. So if I give you an example of this one. To give you an idea. So you can see now it starts running. I'll let this run because you'll see it's pretty quick. It'll be done in no time. So we'll come back to that in a second. And you can already see as well, it starts to produce a draft report, which is something else that you will get a draft report dynamically produced while the analysis is still taking place. So even if it hasn't finished, you can still get some information in the draft to use straight away. So. The other thing you can probably see here is this file hashes. We also, you can export a CSV file containing the hashes and file paths and file names of all of the objects that we detect in the system. So. And then in terms of Interlink, this is where I said you can, for example, compare multiple extractions using these different options that we have here. So things like communication languages, browser history, and also you can put what we call a watch list, so a keyword list, which could be very useful. So, you know, traditionally to compare, for example, 10 mobile extractions together with one keyword list, you can't do that easily in the normal tools. So in like the Celebrite viewer or XRY viewer, it's not possible to do that easily at the moment. You'd have to load each extraction and then run a watch list on each one. Whereas with this, we can do this all together as one analysis step. So I mean, that's pretty much an overview of Leap. It gives you an idea of, you know, what the system looks like, why we think that it's useful for, you know, a broad range of investigations, whether that be triaging use case, frontline use case, or in the laboratory use case. We'll just see how we're getting on with this. So it looks like it's getting there now. Yeah, so you can see it's almost finished. You can see the progress happening here. But you can already understand, you know, we've just scanned 14 videos. Like I said, the actual runtime of these, some of them are around 6-7 minutes. One of them is around an hour. So you can imagine, you know, this is running live on our server, which we host, and you can already see the speed that this is actually analyzing these video files in. So if you had 10,000 video files, if you can leverage that against the time taken for a person to look through them, you can imagine the advantage that we've got with this. So again, this is picking out guns and things like that. So yeah, we're almost done. So I think I'm a little bit early maybe, but that's kind of, you know, an overview of Leap, and, you know, where we see it being useful. I think we can probably take some questions, because I already saw before that there was quite a lot of questions in the chat. So I'll be really happy to take some more questions for the next 15 minutes or so. I also have my colleague Jim. I think Jim is online in the room somewhere, and yeah, Jim will be happy to also answer any questions that people have as well. So thanks very much.
Yeah. Thank you so much.
Also, obviously, after the session, if you have any other questions, feel free to reach us at the email addresses you can see, and also feel free to reach out to Mukesh at Quicksoft, because he'll be happy to talk to you as well about everything that I've showed you today. So, okay, let's have a look then. So, I'll just scroll through some questions. Let's see. Okay, so there's a couple of questions there I can see about things like Telegram and stuff like that. So it's the problem with Telegram or Signal, let's say, there's certain security measures in place by the makers of those apps, which makes it very, very difficult to access that information. In T3K and with our platform, we don't do any decrypting or extracting of this information. We actually rely on the third-party toolkit, so something like Celebrite or XRY to do that. So we are dependent on the security researchers within those companies to actually either reverse engineer that app or actually find a way to do it. So typically at the moment, things like Telegram and WhatsApp, for example, those can be decrypted and decoded by the latest versions of the toolkits from MSAB, Oxygen, Hancom, Celebrite. Other things, you know, stuff like Signal. There's also some stuff within Snapchat called like For Your Eyes Only, which again, you know, at the moment, it's a constant battle to try and work out a way to decode some of that information. So some of that you won't get that in Leap, and you won't get that in the Celebrite extraction, for example. You would either have to try, if you've got the actual database in the extraction, you can then try and analyze that yourself manually using SQLite, basically. But again, it just depends on, you know, if it's encrypted, you still obviously need to find the encryption key and so on. So it's very tricky. I don't know if that really answers that question very well, but it depends on the toolkit as to what support they've got, and it also, yeah, it depends very much on the app as to whether or not it can be decoded at the moment. Typically, the popular ones will be worked on the most, but yeah. Let's see, what else have we got? So, okay, so there's a question there about face recognition. So the process, yeah, it's very simple. All you do is essentially you upload. In fact, I'll try and share my screen again still. Hopefully you can still see that. Sorry. So in here, you simply you would choose. You could choose a repository of faces that you already have. So this could be, you know, faces of known criminals or faces of suspects or victims that you already have. You simply choose them, upload them into the system, and then when it comes to the analysis part, all you have to do, so if it's a mobile device extraction, just go in here. You simply, in here, you simply choose the different faces that you would like to run the extraction comparison against. And when you do that, then any hits on those face examples that you've got in the system, any hits in the extraction will be shown in the report. So it's very, very simple to do that. You just need an example of the face. Obviously, it needs to be reasonable quality. You know, the face needs to be visible. It needs to be, obviously, you know, a person's face. If it was really low quality, pixelated image, then that might cause a problem. But so that, hopefully that answers the question. In the same, just media data. So maybe you've got 10,000 videos or 10,000 images from some source that, you know, have got different faces in there. You can do exactly the same thing. You simply upload into Leap, and then you would choose here the different faces that you would like to compare. So somebody, let me see. That's an interesting one from Pritam. Do you have a good idea of the most recent hot area of research in the field of cyber forensics? Oh, a few questions there actually. Okay, so I would say at the moment there's lots and lots of research going into IoT devices. So, you know, Internet of Things. So maybe, you know, smart devices like an Alexa or Google Home, smart watches, things like that, because there's actually a lot of data potentially stored on these, but there's not an easy way to extract that information and certainly analyze it. So that's something that a lot of research is going into at the moment. In the same way, there's lots of research happening in the area of the dark web and also around cryptocurrencies, tracking crypto wallets and things like that. This is not something that we do within our company, but because obviously we do actual digital forensic investigations as part of our work, then we're constantly exposed to these types of requests or investigations of this kind. But we don't currently develop a solution, for example, that would do that. But from my experience and my opinion, those are the kind of areas at the moment that are very popular. Okay, so you're asking for a forensic tool that supports both smart device and computer operating systems. That's tricky. That's, you know, if there isn't really a tool that does a great job on everything at the moment. Lots of manufacturers are trying to create that tool, but it's very difficult. I would say, and one that we use would be something like Axiom. And again, obviously, something like Leap, where you can put different mobile extraction data in there, regardless of the tool that you use to extract it, and also media data. Then we're also, you know, trying to make Leap agnostic in that way as well. So and be more of an all-round platform. One of the things in the roadmap for Leap in the coming months is to also support this forensic image format, this EO1. So that'll allow you to put that straight in there and do the media analysis, you know, from, for example, a computer or memory stick or something like that. So let me see. Sorry, I'm just scrolling through and seeing what other questions we can help you with. Oh, lots of thank yous, no problem. Yeah, it's my pleasure to be here today. So there's a question about, does Leap concern privacy criteria? So I mean, obviously Leap is it's controlled in terms of who can use it. So you know, it's got a full user management system, so you can restrict who can access it. You can restrict even, you know, which reports people can see and which sections they can see. It also has an audit log in the background, so that you can go back and see different actions from different users and see what's happened. So I think, is that what you mean by privacy criteria? I think that was from Damini, possibly, what you mean. Also, obviously, we expect people using Leap to be authorized to do that. So typically, you know, it's a law enforcement platform. So, you know, the device analysis will already have been seized or taken from, you know, somebody as part of a criminal investigation. From a legal point of view, you know, they should have followed that already. So, you know, this is not intended to be given to, you know, just anybody to use. It's, you know, it's been designed for law enforcement, government agencies to use. So. Okay, so there's an interesting question from Deepak about how do you deal with passwords? Yeah, passwords are a big problem in mobile forensics in general. However, there are some ways around that now, depending on the device, also depends on the software version of the device. But some tools, for example, Celebrite UFED, there are options within that now to circumvent or even disclose the password on a device. There are also some other options where, for example, something like Celebrite or MSAB, they have the ability to break passwords in their laboratories. So, you know, law enforcement can send devices directly to them, and they will do that as a premium service. But you're absolutely right. You know, in general, with modern smartphones now and the modern operating systems, the password protection is still a huge hurdle. It's still a big problem. Most investigations that we get, the officer in charge typically requests or gets the password from the owner, and normally in Austria, at least at the moment, the owner is usually quite willing to divulge that. In cases where they don't, then yeah, we have to look at other methods, either using specialist tool like the ones from Celebrite, from maybe Grey Key or similar, or you would have to send the device to a special lab essentially for them to bypass that. Is the data can be recovered from a formatted mobile phone? It depends. Again, typically no, but it just depends on the mechanism used. So, for example, with an iPhone, let's use as an example, it uses file-based encryption. So, if you reset an iPhone back to the hello screen, typically you won't be able to even if you can then get back into that device, you won't be able to recover previous data on there, because even though the data might still be present in the storage. Might still be present in the storage. It's actually file-based encrypted, so every file on there is encrypted with its own key, and those keys have been lost since the reset. So, yeah, it depends, but it's usually very tricky to do that with mobile devices. So I think, one second. Okay, so the question about deleted data, again, I keep saying this probably, it does depend, but like, for example, a lot of apps and a lot of the apps that you use on a device, typically they store their information inside a SQL database, SQL-like database normally. Now, if you delete something, typically the information, it still resides in the database. How long depends on settings within the database and also on the phone. But normally, it's usually possible to recover some deleted information, and typically that comes from analysis of these databases. The forensic tools will try and do that for you automatically for the most popular apps and locations. Sometimes, though, if it's something, it's an app that isn't supported by the toolkit, you would have to do your own SQL analysis on that database and do that. But it is possible, yes, to find some deleted information sometimes. Obviously, there are things like vacuum settings within the database parameters that if the app developer has chosen to do that, on a regular basis, then that might clean up the deleted portions. But typically, from what we've done, we often find at least some deleted data from devices. Any more questions? I think I've tried to scroll through as many as I can. Question on conditions where data cannot be recovered from the phone. Yeah, again, typically if the phone is encrypted, obviously, if you don't have the password or the encryption key, it can be very, very difficult, if not impossible, to do that. Also, as I mentioned, with something like iOS device, because of the way it uses file-based encryption, and also the encryption key stored in the secure enclave area, once you delete that key, which is instantaneous, then essentially you won't be able to recover any of that data anymore. So even though the data itself is still on the device, it's all encrypted and the key is gone to actually enable the decryption. That's why you may have seen things like remote wipe with iOS devices, that you can somebody can send a remote kill signal basically. If that happens, the actual data on the device is not wiped. It just wipes the encryption key in the secure enclave area, and then all the data is useless then. So it's effectively the same thing, and you won't be able to recover that, unfortunately. And also lots of I'm pretty sure the latest version of Android is moving on to file-based encryption by default, which basically means you don't just need to know one encryption key to get to the data. You need to know every key to get to every part of that data, and the challenge is immense then. So companies like Google and Apple are constantly, it's a constant battle between them improving the security, which as they should for users, and then the digital forensic industry to try and find ways of getting around that. So. There's a question there about whether LEAP can be used in cyber trafficking. So, I mean, it won't track live data, for example, but it could certainly be useful to get a very quick overview of, maybe, yeah, like you mentioned, phone numbers, contact list, things like that. But it wouldn't be, you wouldn't be able to ingest call data live and be able to trace a call, for example. But you could certainly, if you had some information based on, you know, the person you're trying to find, then you could certainly put that in as a watch list, for example, or yeah, use the Leap report to get an overview of different information on there. So. Okay, so there's a question about, does the software require human intervention? So as you've seen me go through it, it requires human intervention to go through the GUI, but you can automate almost everything that I've showed you. So you could have, for example, a user create a profile here like this, a custom profile, to do different parts of the analysis like I've described, and they can set that as an auto run. So that then after that, there's no more user interaction required. You simply put the extracted data in the folder that the system is watching, and then the analysis runs and the report comes out automatically. And in terms of the reliability of the report is the same every single time that it's run. So the reliability is based on the data of the device. So as long as, you know, the original toolkit used to extract the data has done that properly, which, you know, if you're using things from companies like Celebrite or Oxygen, etc., you know, they test and develop their tools specifically for that purpose. So, you know, they're the experts in doing that. So the actual data from that should be very reliable, and then obviously our report is based on that data. So again, reliable, and the report is the same. It's a standardized thing every time. So. So look, oh, there's a question about detecting malware. That's so this what we do here is not designed for that. I'm afraid. And in the same way, in terms of decrypting password protected files, that's not possible to do in Leap. However, you could use a third-party tool to do something like that. Question from Keaton about keyword searching. Yes, so that's when I talked about the watch lists. That's exactly what that is. It's keyword searching. You can basically create different types. So not only keywords, you can look for hashes, URLs, location coordinates, etc. You can also use what we grep, if you know what that is. So basically regular expressions as part of the keyword search, which also, yeah, you can have a very specific keyword search using that method as well. So, is there any questions that you'd like to jump in on, Jim? I don't know if you can hear me or you're actually here still. Anything you can see in the list there that's of interest? Oh, actually, I can just, sorry, just a quick one. There's something about, does Leap provide output from the cache and thumb data? Yes. So basically, images in cache or images in yeah, thumb caches, thumbs DB, etc. That's no problem. We can run the object recognition across that as well. As long as it's in the data source that you've put into Leap, then we can do that. Any more questions that I can answer, or yeah, I don't know. Are you there, Jim, or? Maybe not. Oh, sorry, there's a question about incognito mode I can see there. So I mean, something like that, typically the forensic toolkits can extract some data, but normally, so incognito mode wouldn't typically save much in the way into cache or into browser history files, but you might still get stuff from deleted space or from an allocated space that you could recover. But certainly you wouldn't get, you know, like a really comprehensive internet history with the full structure in the way that you might if you didn't use incognito. So, you know, from a cache file or similar from Internet Explorer, you'd have to basically search for fragments of that structure from in deleted space to find something like that. But it is possible to do it. It's not possible to do this in Leap because, again, that's not what it's designed for. But in other forensic tools, you could do that. So I think I'm pretty much